For this, please let me know. I've just started the recording, so I'm assuming that anyone that joins. Oh, hang on. It's recording, but it's not recording the video. That's a shame.
That's a bit rude of it.
It's recording the transcript. I've done this before where it's done the transcript only, but not the recording the video, and I'm not sure what I've done wrong. Meeting options, it's probably that.
One of the many things we all love about Teams.
Yeah. Oh well, looks like I'm not going to be able to record this. The video anyway. That's a shame. Okay. Oh, there's Richard. Oh, that's good. Rick. I love that, Rick. It's so funny.
Oh, that's brilliant.
Cloud Guru, here I am.
So apart from being crazy, Rick is also someone who knows a lot about the cloud.
There are a lot of
So this is going to be like an open round table, really. I've got like a presentation that I thought we could use as kind of a baseline for what we're going to talk around, but you know, we'll kind of just talk around that. But yeah, Rick is a bit of a guru. Let me start off by sharing my screen. What's that? Are you denying you're a guru?
On paper.
On paper. Okay. Let me just find the presentation and then we can go forward. There we go. That's the presentation. Can everybody see my screen okay? Is that a yes or a no?
Yeah, it looks great.
Yeah. Okay. So this presentation is one that I did to a Microsoft group about the difference between Azure, AWS, and GCP. And I'm so sorry about my pronunciation. I'm from England, so I will pronounce Azure differently to the way you pronounce it. And I apologize for that in advance.
Doesn't bother me. Half my family lives over there.
Oh, really? Cool.
You sound
cool.
lovely. You sound just like them.
You feel at home.
I just saw them for Christmas, so you sound just like them.
Perfect. I'm glad I've made you happy, Beth. Okay, so this is a little bit about me. My LinkedIn is on here. I will give out these presentation slides so you've got access to all this information. I've got quite a few certifications, but if you look at Rick, Rick has got a lot more than I've got. He's got all of the AWS ones, I think now, Rick, is that right?
Mm-hmm.
Yeah, he's got many Microsoft Azure type ones and Google, the GCP ones, right? The Google Cloud ones as well. Is that right? Something like that. Yeah.
All I do is read books. Can't do anything, but I can read a lot of books.
And if anybody else wants to chip in, I think I just saw Rob on, who works for the Orca security company. Is that right, Rob?
Yep, that's right.
Yep. So he's a bit of a cloud guru too. So anybody that wants to chip in as we go along, you know, just shut me up and just jump right in. I'm going to say a few things and then I'm hoping most of the stuff I know is AWS and a little bit of Azure. But Rick knows a lot about GCP and Azure. So hopefully whenever I don't know that stuff, he can chip in and say a few things about that. So generally the basics about the cloud, why are people using AWS, Azure, and GCP? For me, these are the things I've found. Obviously, others can chip in. You know, customer preference. So I work for a consultancy. So our customers come to us and say they want to use AWS, Azure, or GCP for a particular reason. Sometimes it's for compliance. Sometimes it's for saving costs and that kind of thing. A lot of people are used to this loop here. I don't know if you can see it because there's a little thing over there. This loop here, it's like a virtual cycle that the more customers that someone has on AWS, Azure, or GCP, or the more infrastructure they have, or the more AWS usage or Azure usage they have, the more economies of scale they get, and that means they lower their costs, which then reduces their prices. And if they're like a SaaS provider, which is a provider that provides services via the cloud, then they can get more customers and get more and more of those reduced costs and so on. If they're not SaaS, which is software as a service, if they're just doing things like IaaS or PaaS, which is basically infrastructure as a service or platform as a service, then they get the economies of scale from using more infrastructure or using more services. But basically that's the big drivers. Usually the price reduction is the big drivers, usually, I find. Does anybody disagree with that? Has anyone got anything else to add to that? Rick, any other drivers that you think?
Well, I think on paper, yeah, it sounds like you're going to save a lot, but in reality, you lose a lot of money because you're not optimizing what you're using. There's a lot of orphaned resources, not right sized. You're not doing the good cost, really good cost saving measures. So, I mean, it's almost a full-time job trying to figure out, what you should, what your resources should be and how you should use them.
Yeah, so that's a big part of working in the cloud, is trying to work out how much you're using and how to reduce that. And we'll talk about that, as we go along. But Rick and I both worked at a company called Micro Focus, where we put a lot of stuff up in the cloud, and it's really easy in the cloud to just kind of start up a new virtual machine or EC2 instance in AWS. Just start one up and forget that you started it, really, and just kind of leave it hanging. And maybe it's using resources, or maybe it's using hard disk space, or what have you, or even just having files up there that are costing storage costs that you don't really know that you're paying, that kind of thing. So that's one of the things that we have to watch in the cloud. So we have to monitor this cycle and make sure that we really are reducing prices and reducing costs and so on. So that's a good point, Rick. Anyone else? Anything else on that?
I think just time to market, right? Like the promise of cloud is just being able to be more agile to the business, right?
Right.
You're not waiting on infrastructure to stand up, or teams to align on purchases and things like that. It's just you can go as fast as your developers can move, and that's as fast as the business can make decisions. Right.
And that's another thing between the IaaS, the infrastructure as a service, and the PaaS, the platform as a service. The more you can move towards optimized for the cloud, using a platform rather than just the infrastructure, typically you're going to save more money. The reason being, infrastructure costs money to run, even if you're doing it in the cloud, of course. And platform as a service, typically something like an Azure function or a Lambda function, is only going to run when it's actually requested, that kind of thing. And then you're only using kind of infrastructure costs while that thing is running. So theoretically it should be a lot cheaper. So there's different ways to optimize towards the cloud and reduce those costs and so on. So I wanted to put these 3 links in here. They're cloud dictionaries, which came from a cloud guru, and they're very good. So I've put the links in here. So as I say, I'll give you all the slides after this, so you've got all these links. And they basically just take you through all the kind of terminology that you'll hear in the different clouds and what they all mean. And I think they're just great. So I've put those on as a slide here. Oh, sorry, I've done the wrong thing. So they're very useful. This is the benefits of the cloud according to AWS. I just took this from one of the AWS pages. They think that their average customers get a big infrastructure cost saving around 31%, a cost that it's a lot cheaper to manage the infrastructure typically. So typically 62% saving. Now, when they're saying these savings, you've got to remember this is comparing to what it would be to run the same infrastructure sort of on premise. Okay. So remember, when you're running on premise, you're going to have to order your infrastructure up front. You're going to have to pay for it up front. And you're going to have someone in the company who knows how to set it up and manage it and that kind of thing. And typically, there's a lot of work involved in that. Whereas when it's running in the cloud, some of that is taken care of by the cloud. And we'll see as we go along that there's more and more of that can be taken care of in the cloud by various systems and options, depending on which cloud you're in. So although they say 62%, some people will be skeptical about that. Some people will say it's more than that, so just take that with a grain of salt. But these are the kind of things that people think they benefit from in the cloud. This is what I think, is it Rob was saying, that, faster time to market, more features delivered per year, that kind of thing. Reduction in unplanned downtime as well. So, typically in the cloud, you have self-healing systems, you have systems that can come back up quickly, depending on the settings and the configuration and that kind of thing. So you can reduce unplanned downtime. Also, you can have kind of duplication redundancy, so that if one goes down, the other one can take over, that kind of thing. For example, a virtual machine, if it goes down, another one might take over. You might have a load balancer managing that, and so on. So I think that's really where that benefit comes from. And fewer security incidents per year. For example, in AWS, there's a whole swathe of tools that help with security. There's the WAF, there's Guard Duty, there's AWS Config, there's all kinds of security policies. There's so many things. Anyone want to add some things to that? I know Rob will. Rob, do you want to add some security stuff there?
Well, I mean, just in general, the cloud has this shared security responsibility model, right?
Mm-hmm,
and so,
mm-hmm.
You are ultimately responsible for securing your data, and they try to give you the tools to do that. But there's a lot of ways that, people can either make mistakes based on, just forgetting to do something. They can make mistakes, just over time with, drift and shift and change.
Yep.
And there's a reason that there's a lot of certifications around the various cloud platforms, because they're not necessarily the easiest to use from a security perspective. So,
right.
We can talk about it later, but
Yeah.
Orcas definitely exists in that realm to try and make that easier and make it so that you don't have to be a specialist on all platforms and all things.
Uh-huh. And Rick, do you have some security stuff to add to that, given that you work for Micro Focus?
No, I mean, they all, right. There's no way you're going to be able to get the depth of the security infrastructure that you get from the cloud vendors, because they have, some, like you said, economy of scale. They have so much money to develop this stuff and best practices and implement those. And I mean, it would cost you a fortune to get all that software to do DDoS prevention, to do the WAF stuff, to do firewall and just the secure infrastructure. That they have so many compliance certifications for government and HIPAA and SOX, JSOC, whatever. They have so many, because they've really hammered down on the security of their infrastructure.
It's a lot easier to be secure in the cloud. I think comparing it, I've worked for a number of clients who host their stuff on premise, and seeing how much there is a lack of conformity, a lack of configuration, and generally bad practices typically on-premise systems. I see that typically those in the cloud do better. That's my perspective. Now we at Micro Focus, we used something called Terraform to help with that. Terraform makes everything, all the configurations pretty much standard if you write them correctly. Terraform is basically infrastructure as code. And it's a bit like CloudFormation templates in AWS, or like Azure resource templates, and I'm sure Google has something similar. So Terraform allows you to really write your infrastructure as code, and we used something called TerraGrunt on top of that, which was fantastic. It basically set up all our accounts in AWS, one of which was a security account. It set up all the IAM profiles, so that's basically all the identity and access management stuff. It also set up the security policies. It set up firewalls, all the correct ports, open or closed, whichever way. It set up WAF for us. It set up all kinds of like control tower with guardrails, all kind of stuff. It was amazing. So, if you want to in the cloud, you can do everything really well. That's the point. So, cloud enables that. It doesn't enforce that. So as Rob was saying, that there's some parts that are dealt with by the cloud provider, so AWS or Azure, but there are some parts that are your responsibility on top of that. So you can do all that, or you don't have to. So, they're not going to make you, and no one's making you, but obviously if you want to prevent security incidents, then it's obviously a good idea. Okay, so let's talk about cloud evolution. So the way I see it, seeing all the customers that I deal with, on-premise, is still around quite a lot, and hybrid is still around a lot. And I think a lot of the cloud providers are realizing now that although they thought everyone was going to go all the way up here, up to optimize for the customer kind of SaaS type environments, multi-tenant, that kind of thing, where it's software in the cloud as a service. I think really what's actually happening is a lot of stuff is staying around here and will stay around here forever, or for a long time. So on-premise code is there. So now a lot of the cloud providers are providing new tools to help you to manage your infrastructure on premise, and there's all kinds of ways. We can look at some of those tools later on. I've got a few slides on that as well. But generally speaking, the kind of ideal is that people go from on-premise up to hybrid, up to full cloud. That's kind of the ideal. And then on this side, most people that go originally into the cloud, they do some kind of lift and shift model. For example, they might even just move their databases into the cloud. Like if they've got SQL Server on premise, they might just move it to the cloud and just change the connection string to point to the SQL Server in the cloud. Another lift and shift would be just to take a virtual machine that you've got on your on-premise and move that up into the cloud, or a physical server, just basically copy what you're doing in that server and move that to the cloud. So that's that kind of infrastructure as a service, kind of reduced management thing, where it's less management to run it in the cloud. And then people start to think, oh, well, actually, if I really use the cloud well, I can do things like use Azure functions, or I can use things like Lambda functions, or I can use workflow type things like steps, AWS steps, that kind of thing, or event grids and more complicated stuff, that kind of thing. But stuff that's a bit more self-managing, that's kind of running as a platform, where basically AWS or Azure or GCP, they manage it for you. And all you need to do really is kind of throw a piece of code at it, and it will run in the cloud, and it will self-manage in terms of scaling and availability. So if it goes down, it'll come back up, and that kind of thing. And somewhere between these two is things like, the Kubernetes and the containers in the cloud as well. So kind of people are moving up this this slide up towards more towards PaaS really. SaaS is a bit more specific to people that want to offer, you know, a full suite of software services to a number of tenants, a number of clients in the cloud. This is, you know, a bit more specific to certain types of companies, really. Anybody else want to say anything about this stuff? Nope. Okay. So in the cloud, don't forget that you've got requirements, and requirements are still the same whether you're in the cloud or whether you're on premise typically. However, in the cloud, it might be easier to fulfill some of those requirements. Accessibility, how easy it is for people to use your software, whether it's you know, they're accessible on phones and on laptops and iPads and what have you, or whether it's like if they're hard of hearing or they're not great at seeing, you know, is there that kind of accessibility, that kind of thing. Availability, obviously the cloud makes it fairly easy to do things like load balancing, so that if one server goes down, another one might come up, that kind of thing. Capacity planning and scalability, again, the cloud can help you with that a lot. You know, scaling groups and so on, depending on which cloud you're in, what the name of that is, allowing you to scale up or scale out and so on. Deployability is, you know, how it actually gets out there. So how does it get out into production, and which loops does it have to go through to get to production? So does it start off in dev and then go to QA and then into production, or are there packaging situations going on before it gets up there? Are there testing scenarios going on before it gets up there, and so on? Configurability is all about you know, having parameters and files containing those parameters for the different environments or what have you. Normally YAML files or JSON files, depending on which cloud you're talking about and which system you're using or which tools you're using. Governance, we've talked about a little bit already, things like HIPAA, SOX. You know, GDPR is another one in Europe and so on. So, you know, Azure and AWS help a lot with governance. They can provide documents for you that prove that their cloud is compliant to a certain level. And then there's the level that Rob was talking about, where you know, your responsibility is the next level up. And that part you have to make sure happens. And you can do that with, for example, in AWS, we talked about things like the WAF and things like the AWS config. That there's all kinds of tools that you can use in AWS that help you with that. I don't know about Azure and GCP. Do you want to say something about that, Rick? Governance stuff.
Yeah, they all have similar types of tooling for that.
And then there's maintainability. So that might be code. So you might be talking something like Git or GitHub, that kind of thing. Obviously with Azure, there's they have the whole build and pipelines thing built in, and kind of CI/CD plus DevOps kind of environment. And then security, you know, IAM is basically in all three clouds, obviously mostly based on a kind of Active Directory model, but, you know, talking about users, roles and groups and that kind of thing. And then there's things like security policies and firewall policies and so on for security. Basically the clouds make those kind of things easy. And the sizing we talked about already, about, you know, how big you want your original virtual machine, and then if you want to scale it up or scale it out, and that kind of thing. So cloud requirements are very similar to the ones that you have on premise. It's just that it's in the cloud, so some things are a little bit easier to do, I think. In all of the clouds, there's some form of regions and availability zones type thing. I think in GCP, they call it zones. The availability zones are called zones, but pretty much they're similar in concept. How many of them there are and in which areas differs, of course, but basically they're just areas where infrastructure exists. And typically when you're using, AWS or Azure, you have to know which region you're in or which availability zone you're in when you're using the infrastructure for various purposes. And for example, if you wanted to create a load balancer in AWS, typically you're going to have one virtual machine, one EC2 instance in one availability zone and another one in another availability zone, so that if one availability zone goes down, then you've still got the other one running for failover and so on. Anybody else want to say anything about availability zones, regions, anything like that? Everyone's being very quiet. Okay, so this is a typical availability zone in AWS. I just wanted to show you what that was, just in case anybody didn't know. So there's availability zone A and B here, and you've got the ability to fail over from one to the other. So in this case, you've got a web server, application server, and a database server in each availability zone. So you've got the whole stack there. And the Elastic Load Balancer basically points at one availability zone or the other, depending on how it depends how the load balancer is configured. But typically, if one availability zone goes down, then the other availability zone would be used. Sometimes the two will be running parallel most of the time, 50-50. Sometimes one will be hot, one will be cold, and so on, depending on how you configure it. But that's pretty much what that is. Any questions anybody's got so far? Anything anyone wants to say? No? Cool. If you hear anybody snoring in the background, that's my dog. It's not me.
We have the same here, snoring dog.
So yeah, this is about. Oh, go on.
I was just going to say that the typical load balancer architecture is there's also there's way to do the same thing through DNS, and there's multicast solutions that are good for like global solutions to route traffic to the closest region or the region with the least latency, or to keep it within a specific zone. So there's all kinds of ways to load balance traffic.
Yeah, that's the higher level stuff, right? So so in Azure that would be front door, right?
Yeah, exactly.
Yeah, that kind of thing. So basically the idea of that is if you're in Australia, you want to get to a closer version of the application than if you're in America, then you might be routed to the Australian server rather than to the American server, that kind of thing. So there's another level of availability above this for those purposes. Yeah. So this is about accounts and subscriptions. So Azure is pretty different to AWS in this regard. In AWS, an account owns the resources. In Azure, it's more like the subscription owns the resources, really. An account may have many subscriptions, I believe. Is this right, Rick? Can you tell me if I go wrong? Rick knows this stuff better than I do.
Yeah, I mean, sure, you can have as many subscriptions as you want, but the resources can only be a part of one subscription at a time.
Right. So I believe that you might have one tenant with many subscriptions, for example, even in a multi-tenant environment. So you might have, for example, in one account that I worked on, there was an account and then there was a number of subscriptions, but the subscriptions were owned by different tenants. So we were a multi-tenant environment. So we had, say, Coca-Cola was one tenant and they had multiple subscriptions, one for dev, one for prod, one for staging, that kind of thing. And then I don't know, Walmart were another company and they had subscriptions too that had, dev, stage and prod, that kind of thing. So there's different ways that you can implement that. It's kind of flexible in some ways, but that is a little bit different between AWS and Azure. So this is, oh, sorry, I'm going up. So this one here is the GCP resource hierarchy, how Google Cloud kind of does it. This one is the AWS on the left, and this one on the right is Azure. So that's a little bit confusing, sorry. This one over here is Azure, because you can have an account with subscriptions and so on, and you have many admins for that. This AWS one on this side is more like the account owner owns kind of all the resources. Okay. So just about all of the functionality of IAM, depending on how you pronounce it here, is similar in the three clouds, AWS, Azure, and GCP. They're all kind of based on the kind of Active Directory kind of model, or LDAP as the old days we used to use. That kind of model, the idea of having groups, the idea of having users, the idea of having roles, and having kind of policies, really. So pretty much they all work in a similar kind of way. There's slight differences, but that's kind of how it works. Does anybody want to say anything more about how that works? I know AWS is very limited. The IAM is very limited. It only allows 5,000 users, for example, in IAM. So typically a lot of big companies in AWS, they tend to use Active Directory really with AWS. So that's pretty common. Anybody else want to say anything on that? No. So IAM is Identity Access Management, and it handles things like authentication and authorization. So authentication, Rick knows a lot about authentication. Authentication is really about saying, are you who you say you are? So it's either something you know, like a password, something you have, which might be like a device like my iPhone, or something you are, which might be your fingerprint or your iris pattern or something like that. So that is the first level of security, really, the authentication. And then authorization is, now that I know who you are, what are you allowed to do in my system? So, for example, I know you're Fred, so you belong to the group of Freds over here. So because you're in the group of Freds, you're allowed to do Fred things in my organization. You're allowed to manipulate the Fred server, and you're allowed to set up the Fred database and that kind of thing. So that's kind of how that works. Is that a good explanation? Has anyone got any questions on that? Anyone got anything further they want to add to that? Rick, you could go on forever about authentication and authorization, I think.
Yeah, why I'm seeing this is they are, each GCP, Azure, and AWS all they're very different as far as how they implement, all this stuff. So it's like, even if you learn one of them, and I've always found it difficult to like separate them without some like re-education when I'm focusing on the different cloud is how all the access control works and all the options available. AWS feels the most native. It's the most normal, the easiest to understand for me. I don't know. And Google seems like it's the hardest because it's a whole separate site that handles their accounts and whatnot.
Right. Yeah, I mean, go on. Did someone say something?
Yeah, Michelle, I was going to add that I think what we see when we're taking a look at client accounts is, the biggest challenge with IAM on all three platforms is the long-term maintenance of it, right? I think a lot of people try to start with like maybe just 2 or 3 types of roles, and they end up with too many permissions on those roles. Yeah. And then they onboard hundreds or thousands of users, right? And suddenly you've got way too many people in the organization with way too much access.
Right.
And so, one of the first things we see when we activate our tool set is, how many different types of roles and how many different types or how many specific users we can help a client pare that back on, so that we could say, hey, this set of user accounts, right? They're really only accessing 10% of the systems they have access to. You need to take away all the permissions to all these different groups of systems that they just never use, right? And then the second part is, hey, you've got these roles that if you took those, let's just say 3 roles and you split them up to 7 or 8 or 10 types of roles, that would more adequately represent the usage of your users and the permission sets that they need, because you might have 100 users that have 50 permissions and they really only need 10, right? And so the challenge with both of those situations is all the breaches we hear about in the news, they all go back to someone getting someone's credentials at some point in time and pivoting through an organization, right? Like we hear a lot of the more glamorous, like someone dropped a remote code execution issue or some other vulnerability was exploited, but usually that comes back to it let them get a username and password or some sort of credential to then pivot through the organization.
And that comes down to that least privilege principle, right? So in any auditor that comes to your company that might do a SOX audit or what have you, or a HIPAA audit, or just about any audit, the first thing they're looking for is the least privilege principle in anything you're doing, like any system that you set up. Are you only giving people what they really need to do their jobs? And sometimes it's really, really frustrating for programmers or for people who manage the infrastructure in cloud and so on, because they're only given exactly what they need to do their job. And if they need to just go slightly outside of the bounds of that, they have to ask for extra permissions, and it takes a while, and you know how it is. So sometimes that can be really frustrating, but the reason for that is because of these breaches, like Rob's saying. They typically happen when somebody has not been applying the least privilege principle and has given somebody either more access than they need, or has continued to give them access after they've left the company, or after they've left that role. The reason I'm talking about all this is because I used to be an auditor. So I used to do the Sarbanes-Oxley audits and CISSP audits. So, that is one of the biggest problems for anyone, not just on the cloud, for, on premise as well.
And I think to add to that, an auditor only knows what the company is willing to reveal to them, right? So, at some point, the auditors really aren't culpable for, if someone's over permissioned, right? Like it really comes back to the company that convinced the auditor that they gave them just the bare minimum. Right. But what we find is that it's definitely not the case, right? Even some of the largest companies in the world that are passing their SOX audits, passing their, whatever audit they have, right? They're still guilty of these same sins. And I think, you touched on another important point, people leaving companies, or just the hustle and bustle of everyday life, right? There's a lot of accidents that occur with credentials. So we find a lot of like SSH keys sitting on systems, or, like Amazon IAM credentials are stored in text files, right? In like
hard coded in the code.
Right. They're just sitting out there in things. And a developer was just going really quick and built these systems and moved on to the next thing. And suddenly, you have something in production that has this time bomb waiting there, right? And those are all things you have to really hone in on. And I think this is one of the biggest areas for improvement, and one of the biggest areas for any company adopting cloud to really hone in on using a tool set that can find these problems for them before they turn into a disaster that requires an incident response team, right?
Yeah. And while we're talking about that, the password policies in any organization, whether it's on cloud, on premise, or hybrid, or anything, the password policy is one of the biggest issues as well. The fact that, how often do they have to change their password? Can they reuse one that they've already used in the past? Is the password that they're allowed to use one that's like 15 characters long, or is it only 5 characters long? You know, that kind of thing. Mixed case. Do they have to have you know, funny characters? Are they allowed to use those? That kind of thing. So, you know, you get to the point where it becomes like very difficult to remember your password, or it gets to the point where the password's almost useless because it's too easy to guess, kind of thing, because password hackers are amazingly clever. So you've got to kind of balance those two things, and now people are using multi-factor authentication instead as a way of kind of backing up passwords, right? So Rick knows a lot about that. Micro Focus, that's one of the big things they do is multi-factor authentication. So Rick, do you want to talk a bit about that?
Yeah, I mean, nobody should be these days. Nobody should be getting access to any cloud resources just with a username and password. You should 2FA everything, and you know, and also in AWS, you should have any rights assigned really to the user itself. You should use roles and assume those roles to do the different operations you need. But yeah, you shouldn't not have. There's no good reason not to have MFA enabled for cloud.
So when he said
have
2FA,
you met the U.S. government?
3FA.
So 2FA is two-factor authentication. 3FA is three-factor authentication. Multi-factor authentication is another way of saying it. And as I don't know who said it. Was that Beth that said about the government? Who said government?
I did, yeah. I
Yeah.
work for the federal government. So
Right.
the legacy systems obviously let you in with passwords because they weren't designed for our credential access pins, multi-factor authentication. They're just not designed. They can't sustain that. On a good day, they can't even on a good day, they'll take your password and your login. On a bad day, they'll just crash. And so, you know, one of the reasons I'm on the call is to figure out how to take one of my legacy systems and literally redesign the whole thing and throw it up into the cloud.
Right.
Because I'm terrified to try and pick it up and put it in the cloud. I'm pretty sure that'll kill it.
Well, there's plenty of consultancies out there that would help you do that. But as far as you know, the authentication mechanism and stuff for the government, I've seen a lot of those systems use SSO and basically have a really strong means of getting in once, which includes multi-factor authentication and so on. But then once you're in, they use SSO for everything. So once you're in once, you can get to everything.
You can get to anything.
Yeah.
Which I don't know that that's the best route, but
well, this is the thing that
chosen to do it.
Right. This is the thing that Rick was saying about assuming a role. Okay. So if you have, you know, a set of users and passwords kind of in one account, which, you know, is fairly well managed, let's call it that, then that once the user logs into that, they can assume a role to get to anything else. And if you do it that way, you can turn off the role really easily. You can, you know, if they leave the company, or if you're suspicious and that kind of thing, you can also make the role have less access so that it can't access certain resources and that kind of thing. Rick, do you want to talk more about that?
Right. You should just use least privileges with everything. So you can create roles for different operations. So if you need to do an administrative function, you assume that role while you're doing that function, and then you go out of that role when you're done. But
so effectively, the user only really exists in one account, for example, but they assume a role to go to any of the other accounts. So that role is the only thing allowing them to access those resources. So if you snip and cut off that role, they haven't got access to anything outside of the original account where they signed in, that kind of thing.
Right. And there's good auditing for that. So you can actually see when people use those particular roles.
Yeah, so auditing is really important for compliance and so on, especially, whenever the auditor comes to you, they're going to want to see that you're auditing the right things, every event that happens in the system. So that's things like user creation, user deletion, user change, anything that changes in the system, really. The same thing for like infrastructure objects, for data objects in the database and so on. All kinds of auditing. So in AWS, we have CloudTrail for that, which does basically you can't change the trail, or if it's set up correctly, you cannot change the trail. I don't know how they do that in Azure and GCP. Does anyone else know? Rick, do you know that?
I think they all have non-repudiation of their audit logs, so they're checksummed, and I believe that I think AWS. I'm trying to remember. They use some type of checksumming.
Yeah, I'm sure they do.
Yeah, they all have the same. They all non-repudiation, so you can't
So,
change the log without somebody say that the log isn't original.
Right. So basically, in court, someone can't stand up and say, they faked that log entry, because it's pretty belts and braces that that you can't contest it, really. And once it's there, you can't contest it. So it stands up in court. That's the big thing. So that's the reason that things like CloudTrail do that and do it in that way.
With that CloudTrail, I do have a question with that. When it's set up, and this from a security perspective, when you set up those identities and those user requests, user accounts, and then their permissions and their different accesses, will it show in that audit trail which access they were in, when they which permissions they were using when they?
Yeah, that's a good question. So it records the role, but it also records the user and password that assumed that role at at the time when so if someone's making a change to a firewall, right? If they're changing the port of the firewall, in the CloudTrail, it will first of all identify the user and the role, and then it will say what they did. Yeah.
Okay. So I would be able to go back and see. I'd be able to cross-reference with their, permissions and things like that. That's been a big thing for us for auditing, is segregation of duties. And like, if you're allowed to do X over here, especially with our financial systems, if you're allowed to do X over here, you're not allowed to touch Y. And that's some of our legacy systems roles and permissions have X and Y crossed. And so we're trying to figure out how to undo that in our new system. So that's something I'm very interested in how to trace that.
In AWS, one of the good ways of doing that would be the security control policies. So, it has like it's almost like an outer shell of security that says people cannot go outside of the bounds of this. So they're limited to only doing this. So, that's one way of doing it. Roles are another way of doing, only allowed to assume certain roles. So that role can do X, but it can't do Y, that kind of thing. But I mean, if you want to talk about that in more detail, we can talk about that after this and go into your specific issues and so on. I'd be quite happy to talk to you about that.
So that's the product that we actually deliver to the cloud, as a governance product that goes out and interrogates your permissions and looks for separation of duty violations and things like that.
Yeah. So what is that product called?
Identity governance.
Identity governance, right? So Identity Governance IG is a Micro Focus product. So it's the CyberRes group within Micro Focus, I think, Identity Governance, and that is what they do. They basically check those kind of things to make sure you don't go out of the bounds of what you're allowed to do, kind of thing. Just before I go off this page, this link here is from a Cloud Guru, and it compares AWS, Azure, and Google in the IAM area, so in this area. So if you want more detail on this, that link is really good for that.
Yeah, they're one of the best trainings out there.
Yeah, they are very good. Yeah. Okay, so now we're going on to something really boring. EC2 instances. So EC2 instances are basically virtual machines. So in Azure, they call it a virtual machine. EC2 instance in Amazon, in AWS, and in GCP, they call it a virtual machine, a VM, same thing as Azure. So basically, this is like, you know, in the old days, you would have your server room or your you'd have some kind of area where you keep your servers, and you'd get your server, you'd buy it, you'd purchase it, and you'd say, what do I need? I think I need this amount of memory and this amount of hard disk space and this amount of CPUs and that kind of thing. And you'd order it and it'd come in 5 weeks time, and you'd find you'd ordered the wrong thing and you'd have to send it back, and or you wouldn't have the right cables and what have you. So that was a real pain, right? Now in the cloud, you can basically just click, you know, they call it ClickOps. You can click and create a virtual machine in the cloud with a few clicks. You can do it that way, or you can do it with things like Terraform, or you can do it with things like CloudFormation templates, and we'll go into later on what that is. But basically, it's really easy to set up a new computer in the cloud. In some ways, it's too easy. As we talked about earlier, pricing can be an issue. You could set up an EC2 instance with, you know, a huge amount of memory and a lot of disk space pretty easily and forget it's there and so on. Sorry, did someone have something to say?
I just say it's very hard to right size a machine, because you have to remember, even if you have a ESXi host, virtualized, some kind of virtualization technology on-prem, or just racks of servers, you can saturate everything with, you know, the network. You can saturate it as much traffic as it can handle, the CPUs, memory, all that stuff. But in
That's
the cloud, you're handicapped. They throttle everything. So you may have enough memory or enough CPU, but you don't have enough network bandwidth, or your disk type is with the performance of the disk you have it doesn't match what you had on-prem. So I've found it very difficult to do like a 1-to-1 between what maybe you had on-prem and what you have in your cloud, because I have a rack of servers in my home, in my own lab, and my servers always blow away just about anything I can do in AWS, just because, like I said, I can saturate them with whatever I need.
Yeah, you can make the choices for how to change stuff a bit more easily. With things like AWS, you know, when you're picking which server you use, one of the things you can pick is, you know, how much network you want to support on that server and so on. But it's difficult to know up front, but that's, you know, really what capacity planning is for, right?
Right.
Capacity planning is meant to be done before you set up the servers. Even in the old world of just completely on premise, that was meant to be done before you set up a server. In reality, it doesn't happen until after you get the server up in many cases. And you see a lot of people don't even know what the access patterns are going to be. So it's pretty hard to predict when it's a new service that you've never offered before. Especially with, you know, Rick he's talking about a SaaS environment, a software as a service environment. It's often difficult to know how many customers are going to use it, and, you know, per tenant in Rick's environment, each tenant can have, you know, thousands of customers. So it's often difficult to know how much usage each particular machine is going to get. But capacity planning is key there. And, you know, typically you're just going to have to roll up until you get to the one that can handle it. So when I say roll up, for example, in AWS, EC2 instances come in lots of different sizes with all kinds of names. I've got here listed the Azure equivalents, which Azure has A, B, D, F, G, H, L, M, N series, and AWS has things like T series and M series and G series and so on. So there's all kinds of different types of machines that you can have, and the machines by default, you know, come with a certain amount of memory, a certain amount of CPU, and a certain amount of network and so on. But you have to keep tweaking and finding the one that fits best, really. Now, the nice thing about the cloud is when you find your overcapacity of this virtual machine, you can just spin up a new one with, you know, more of whatever was missing. Whereas when you're on premise in the old days, you'd have to order it and it'd come in and you'd have to configure it and so on. Here you just spin it up. So it's a little bit easier in some ways, but in some ways it's still tricky. Go ahead, Rick, say whatever.
Oh yeah, I mean, like the cloud vendors, they love that marketing. That's a lot. I think that's a lot of marketing. When they make the comparison to like ordering a server, blah blah blah, and because that was 15, 20 years ago. But it's with that's the thing with the VM, the hypervisors that kind of negated that a little bit, is that you bought a giant hypervisor, then you provision the resources that you needed. So so it's still you only have so much hypervisor availability and storage availability on in your data center, but in the cloud it's unlimited.
Yeah. So so these two links here go into the details of kind of what options you've got with virtual machines in the different clouds, and this one's Azure, the IOPS option. So who wants to talk about IOPS and explain? It's basically disk speed, really. But Rick, do you want to talk about IOPS?
Input output operations per second. It's a magical formula that you can use across all their platforms to kind of help understand the performance. So if one thing does 100 IOPS and then you make 2, then you're going to get double of what you just had. So
right.
It's a unit of measure, but it's kind of a magical formula that only really matters when you're comparing one size to another, just by arbitrarily looking at a thing that has so much IOPS. It's hard to correlate that to some on-prem or VMware server.
Right.
But but if you look like Azure, like they have a DMS, they have a server migration services. They will do an assessment and they'll try to correlate what you have on-prem to what they think that you'll need to cloud. So they have some formulas that they run.
Yeah, that's true. So for migrations, so typically a lot of companies, the first thing they do is have to migrate to the cloud. So a lot of these cloud companies offer all kinds of migration tools. So DMS is the data migration tool from AWS, which Rick was just talking about, and that helps you to move your data into the cloud. There's also like just a migration service, which basically goes out and looks at your on-premise system and says, how many virtual machines do we need, and how many firewalls do we need, and how many databases do we need, and so on, and how much is that going to cost in the cloud, and where should that go in the cloud, and how should that be configured, and that kind of thing. And it asks you questions, things like, do you need extra availability to make sure this doesn't go down, and that kind of thing. And it will work out for you pretty well. It's really good. What your infrastructure should look like when it gets into the cloud. So that's a really good tool. So Beth, you might want to consider using that, or having some help using that. It might be worth, using a consultant to do that with you. But definitely that is a really good tool for it just kind of analyzes what you've got on premise and basically says, this is what you're going to need in the cloud to support a similar kind of system,
One more thing about these. I'm sorry.
I was just going to say, it also tells you the path, how to get into the cloud, what's the best route to getting in. For example, if you've got a lot of files to move, you might want to use something like the Snowball, which the Snowball is basically like a thing that is like a little computer that comes to your office. You copy all the files onto it, and then you send it to AWS, and they load it into the cloud. But then there's also Azure Migration Service. There's also import, export. There's all kinds of ways of getting stuff into the cloud. So, AWS has migration tools that will help you work out how to do that. Sorry, Rick, go ahead.
No, I was back to these, the series. They all work differently too. All these series are there's like some of them, like example, some of them bank credits. So if you have surge usage, so periodically you'll have a high level of usage.
Burst.
They'll bank credits. Say if your CPU was you had a arbitrary value 100. The 100 was the performance you were going to get out of it. You could maybe overperform to like 120 or 130 using credits until if you credit, and then if you exhausted all your credits, then you would be capped at like 100 again until you had enough credits to go above that. So each of these series, they have different things about them that make them unique.
Yeah, and sometimes if you don't use any of your credits, like for example, a lot of retailers all year they're not going to use any of their credits, but suddenly around Thanksgiving and Black Friday and Christmas, they suddenly need a lot of bursts. Then they can accumulate those credits throughout the year, and then at the end of the year use them all then, kind of thing, depending on which infrastructure we're talking about and which cloud we're talking about. There's different ways to get those kind of credits and use them at different periods of time and so on. While we're talking about that kind of thing as well, all these virtual machines, typically there's a way to buy them like in advance. So if you know you're going to use 5 virtual machines this year, you can pay for those up front and get a lot cheaper, get it a lot cheaper, get a big savings. Or you can just set them up on demand and pay the full price. And there are all kinds of other options, like in AWS, there's the spot instance, which is kind of, you just use that when it's a particular price, or you make a bid and you say, I only want to use this EC2 instance when it's cheaper than, X per hour. And you can use those on variable loads. So where, for example, if you want to use a spot instance when you need to scale up or scale out, then that might be a good usage of that if you just want to pay on fairly cheap machines at that point in time. Anybody else want to say anything about that kind of thing, spots and reserved instances and all that kind of thing?
Yeah, so you buy capacity in 1, 2, or 3 year blocks. You can you can decide if you want to pay for it up front, if you want them to be convertible, if you want to pay it all up front, and you could get 60-70% savings. But in order, and you can also use saving plans, which is a newer type of way to save, where you just basically say in AWS, I'm going to spend this many dollars a month, and then for that you'll give me 30% or whatever a rebate, and it's easier because then you don't have, it's basically not just EC2, it's everything you use, and you're just getting a discounted dollar amount. And then and the spot instances, they're really good for batch jobs, things that could be terminated without causing any issues, but mostly for big data, DMR, or was it EMR, and then there's all these terms, and then batching.
Yeah. Cool. Okay, let's go on to the next slide. So this slide is about is kind of just comparing the three clouds really in the main things. So we talked about EC2 instances already and virtual machines on the other two. Object storage, I wanted to quickly cover that. This is something that people that are new to the cloud don't always understand very well. So I just want to explain exactly what that is. So on AWS, it's called S3. On Azure, it's called blob storage. And on Google Cloud, it's called cloud storage. So object storage, you can really think of that as just file storage. It's just the ability to store files, except that blobs can be really anything. And that kind of sounds weird, but typically you're going to have, it's almost like directory structures with files inside them. But the objects can be very big or they can be very small. I forget what the largest sizes are for the three clouds, but they're quite big. Each one of these objects can be. They can be very small as well. Sometimes it's more efficient and more cost effective to store them if they're a little bit bigger, so store them in a group rather than one at a time. But basically it's just to throw some data at the cloud, really. Now, typically now, things like S3 are being used to store what we call data lakes. So data lake is really a whole load of data that can be almost in any shape, and you kind of give it context, you give it meaning when you use the data. And that might sound a bit confusing, but it's really about the data itself not being stored in tables and columns like in the old days of databases or SQL Server type databases, relational databases. S3, blob storage, and cloud storage are more about data just being more fluid, if you like. So, for example, if you think of a personnel record in your company, the first time you put a personnel record up there when you first start up as a small company, you might only want certain information about each person in your company. It might be quite small. There might not be a lot to it. But as the company grows, you might have to store more and more information in a personnel record. And this allows you, this object storage basically says this object is a personnel record. It doesn't matter whether it's got all of the details in it or whether it's got just a few of the details in it because it's an old record. Maybe, one of your employees has been with you 30 years now, the old employees only have a little bit of information in, others have more in. So that's kind of, the data can be kind of any shape, if you like. It doesn't have to have all the columns and all the rows. So that's kind of what object storage is. I know that's a little bit confusing for those that don't really know this stuff, but that's an intro, and we can go into more detail about that kind of later. VPCs, and so the next line down, logical data center, it's called here. A VPC is really what I would think of as a network, okay? And it can have subnetworks, it can have subnets. So a VPC is a virtual private cloud in AWS. A virtual private cloud can have many networks inside of it, but it's kind of one big cloud for a particular customer. And a VNet is pretty similar. Again, it can have subnets and so on. And for networking people, there's different kinds of controls on each of those subnets. There's different addressing for the different subnets within a virtual, well, a VPC or a virtual net, VNet. But basically, those are the three clouds versions of a VPC, a VNet, and a VPC. And then we've got private connectivity, which this we could go on forever about this, couldn't we, Rick? Private connectivity is all about really, if you're doing things in a hybrid style, so you've got some stuff that's on premise and some stuff that's in the cloud. For example, AWS has Direct Connect, which is basically, you can think of it as like a pipe between your on-premise server room and your cloud server room, and it kind of just is like a connection between the two. There are other options as well for that kind of connection, like you can use a VPN, a site-to-site VPN, that kind of thing. But Direct Connect is, a way that big companies that want a very fast connection are going to use Direct Connect typically, and they're probably going to put a VPN over the top of the Direct Connect actually. So that's another thing. So ExpressRoute is pretty similar to Direct Connect. I'm going to let Rick talk about the differences because I don't really know a lot of the differences. And then there's Interconnect on Google Cloud as well. So Rick, can you talk through those three and explain any differences because I don't know them? Are you still there, Rick?
Yeah, they're all pretty much the same thing. You have to buy a private link that doesn't go over the internet from your service provider, and then depending on where you're located, it could depend. It could factor in on the speeds you can get. Obviously, if you're in rural areas, or not in major metropolitan areas, you're not going to get the same level of service.
And I don't I don't know if you can do it in Azure and Google Cloud, but I know there's like an accelerator that you can use with Direct Connect, which basically will, speed things up to different regions and so on from Direct Connect connections and so on. I don't know if you can do that in Azure and Google Cloud yet. Can you do that?
Are you talking about where it uses points of presence to route stuff to through their native backbone?
Yeah, that kind of thing. Yeah.
Yeah.
So there's different speed options and so on, and then these gateways at the bottom. So there's Transit Gateway, Virtual Gateway, and Direct Connect DX Gateway. They call it DX Gateway. So gateways are different ways of connecting all your networks together, whether they're on premise or in the cloud. So a Transit Gateway is pretty much almost any network to any network if you do it right. Virtual Gateway typically is kind of cloud side. Direct Gateway or DX Gateway is connecting to Direct Connect from many virtual PCs, VPCs in AWS. So that's pretty much those three different types of gateways in AWS. Rick, can you talk to VNet Gateway and Cloud Router? No.
You're putting me on the spot, man.
I don't know if you can.
They all do the same kind of thing. They're the entry point to the VPN routes back to the on-premise network, and you could have more than one. You might have not VPNs, but you might have one of these connectivity solutions in multiple regions. And what I would say about them, there's a long lead time where most people, when they first want to do a hybrid, they'll set up a site-to-site VPN because you don't need anybody's help to do that. You can.
Yeah, and it's so much quicker.
Yeah, it's so much quicker. And
so a Direct Connect connection, for example, takes forever. Like I think it was 3 months was the average, wasn't it?
There's a long lead time for that.
Yeah.
And
you have to go to someone like AT&T and kind of get a physical connection from their office to your office, that kind of thing, right?
Right.
Yeah.
And the site-to-site VPN IPsec, it's secure, it's encrypted. I mean, the only thing is the SLA for it. You're going over the public internet, so it could be performance could be not guaranteed. Where
it could be variable. Yeah. So if you're encrypting over your Direct Connect and you're encrypting over your site-to-site VPN type thing, that side of thing is covered. But there are some compliance reasons that you're not allowed to go over the public internet. So for some of those compliance reasons, especially government, Beth, I don't know whether you're in the really secure part of the government, the funny people, but the funny people in the government, sorry, go on. I can't hear Beth. Can anyone else? Is she coming across? I can't hear Beth. Can anyone else? I can't hear Beth. I'm hearing like, oh, I can hear you now. What happened?
There you go.
Oh,
is that better? So I deal with a significant amount of money. We're a financial entity within the Coast Guard, but we also deal with, so anytime there's a pollution response, we handle the oil spill fund, the oil spill trust fund, which is about $8 billion right now, I think, give or take.
Wow.
And yeah. And so because it's a congressionally, there's congressional oversight and Treasury oversight, OMB oversight of the fund, there's some things that we do differently than the rest of the Coast Guard, but we sit underneath the Coast Guard. Okay. So we're answerable to a lot of entities. We just got thrown into the new Coast Guard financial system. So whatever we do with our new programmatic management system, which will probably be some type of SaaS system, customer relational management system that will have a financial component, it will have to tie to the Coast Guard financial management system, but maybe not, because right now that system doesn't actually do everything that it's supposed to do transactionally that we need to do.
Okay.
So yeah, it's super fun. I've got half of the system is on a Oracle financial backbone.
Right.
And some of it's sitting on SharePoint. Let's not even talk about how wrong that is on so many levels. And my boss wants me to have this new system implemented, or at least contracted and starting development within 12 to 18 months.
Right.
Game
So
on.
I was talking more about people like the FBI and the CIA, right? So that they're
So
not allowed to have.
Because we sit under Department of Homeland Security,
Uh-huh.
we are under their rules. So we follow all of DOD's policies on privacy and all of that stuff, but we also have extra security measures in place because we sit under Homeland Security. So we're very unique and special in that, and how we interact on the cloud.
So you may have to use the Gov Clouds. Do you know about those?
We will absolutely, we'll absolutely have to use the DoD Gov Clouds. We'll have to use a DoD IL4 and a DoD IL2 because we do have a public-facing system and a public-facing part of our system. So we'll have to have a DoD IL2 that talks to the public, that then feeds to a DMZ, that then DoD IL4, probably through some type of bot, will have to reach out after the data has been scanned and screened and then pulls that in. We also have some PII that we will be handling, which adds a whole nother layer of super fun to it. And then add in all the financial information that we keep, which has its own level of security that is separate to all of those things.
Okay, so you probably know already that Gov Clouds are very different typically, well, not very different, but there's a lot of extra features to them than ordinary AWS, Azure, or GCP. You probably know that already.
I don't know enough.
Oh, okay.
I know enough to be dangerous, and that's not the best way to approach a contract.
So the way that keys are managed in GovCloud, for example, is very different. They have to almost be rubber stamped by a kind of superior key storage mechanism. So that has to be done. I don't know if you're in the same realm as the other clients that I can't name that I'm talking about, but they had to have literally everything had to be double encrypted using 2 different key mechanisms, that kind of thing. I don't know how much of that you need, but that's available in the Gov Cloud anyway. So, those kind of things are a bit extra. There's a lot of stuff that goes on in Gov Cloud that people don't know about outside of Gov Cloud, right? So
we're not as special as some of the 3-letter agencies.
Okay.
But we're not as like freewheeling as like EPA or like Department of Interior. Like we're still considered the military, so we're definitely under DoD, kind of DoD, DHS, ICE, Border Patrol. We would be classified under that, but we're not quite as like super secret, squirrely, special like FBI.
So are they super secret in the sense that they're saying you have to use AWS or you have to use Azure Gov Cloud? Are they telling you which one, or are they not?
No, not at this point. I will have to use FedRAMP.
Okay, yeah.
Which will drive me to the cloud sources, but then it's pretty much going to be up to me based on, but then it's really based on who I pick as a service as a software provider.
So FedRAMP is kind of that tunnel, really. There's sort of double encrypted tunnel that we were talking about that basically lets you get in securely. Okay, so that's kind of what we were talking about.
So that's I have to go through there. So
Right.
that's where I have to use a vendor that's FedRAMP certified, that
Right.
has all that, which all of these are.
Yeah. And you have to go through a really like a procurement process is very, very strict, I'm sure, for your situation. So it's not, you couldn't
Oh
just
God,
come
yeah.
to me and my consultancy company and we could do it for you. It has to be someone that's approved already and that is, you know, in the procurement. Mm-hmm.
I could, if you met all the requirements.
Right. Yeah.
So like if you met, if you said, we can set you up on AWS on a DoD IL4 and IL2, and we could administer it and we can do X, Y, and Z for you, and you meet all those requirements, then yes,
Right.
I can come to your business.
Yeah.
If your business doesn't meet that and doesn't, meet it doesn't have like a DUNS number and doesn't have all the things to do business with the government, then no.
Okay.
We could do a consultant, like we could probably bring you in and have you consult, or you could partner with another company that does have that. But yeah, I can't do that.
I get it. And that's typically what I think we normally would do. We'd normally have like a company that comes in with us to do that kind of stuff. Yeah.
Well, and it like if your software is something that runs with like an Oracle, I forget what Oracle's new platform is, or like the Microsoft platform that's the service as a software, that's their customer relations management, or Salesforce, something like that.
Mm-hmm.
If that's something that, so right now I'm looking at SAP, Oracle, Microsoft, Salesforce. Those are the 4 big ones that I am going to look at, because they're all going to meet the requirements that have been levied by my boss.
So
they're
that's
all
a good example.
going to have this capability to go on to the FedRAMP cloud, where someone's going to have the ability to put that, they're all large enough companies that they're going to have partners that are going to be able to do that.
Right. And that's a good example of what we were talking about before about SaaS, SaaS, software as a service. So Salesforce, that's available in the cloud as a service, as a software as a service. So, Salesforce take care of everything for you, right? So you don't have to set up servers, you don't have to run code, you don't have to set up users. Salesforce does it all for you in the cloud. And you just use it, really. It's a bit like Office 365, the Oracle platform you're talking about as well, which I can't remember the name of either.
Thank you. No one can.
A lot of those kind of services, they're software as a service. So that's what we were talking about earlier. So that's a good example. That's good. I've got another slide here that's about the disk offerings, but we kind of talked about that already, so I'm going to skip that one. Blob storage, we kind of talked about. I said that you can have it in hot, cool, and archive tiers. The archive is kind of cold data, so data that you're probably never going to use again, but you might have to get back at some point for some reason. So blob storage typically is going to have these 3 tiers typically. The archive is things like stuff that you might need if there's an audit, or if there's like a court case or something like that you might have to get back if there's something like that, but mostly you're not going to use it. Hot and cool. Hot data is data that you're going to use daily probably, or you're going to use a lot. And cool is the kind of in between. So it's data that's not quite as commonly used right now, but you're still going to access it once in a while, that kind of thing. So they call hot standard in AWS, they call cool infrequently accessed in AWS, and they call archive glacier in AWS. And I'm not sure what they call it in GCP. Does anyone know what they call it in GCP? No one knows. Okay. So that's blob storage. Then you have Azure file shares, and they're similar in AWS. It's called elastic file shares. There's file store in GCP, and they're basically similar to the traditional SMB or NFS type file systems that you might have used elsewhere. So all three clouds offer that. Then there's queuing services. So Azure has queues, which is very similar to things like MSMQ, which is the Microsoft MQ that used to exist on premise kind of thing. AQMP, which is kind of a protocol for message queuing that RabbitMQ uses and other queuing mechanisms use. And then there's SQS in AWS, which is how you do queues in AWS. There's other things as well, like Kafka and all kinds of other options there for different types of queuing and messaging and so on. Azure Managed Disk is very similar to AWS EBS volumes. So AWS EBS volumes is really what you can think of that as hard disks that you might have in your laptop. You used to have on PCs, you'd have hard disks. In your laptop, you typically have SSD disks. It's that kind of thing, and attaching that to your virtual machine. So that's really what managed disks are. So in Azure, I think that's called managed disks in Azure, and in AWS it's called EBS volumes. I'm not sure what it's called in Google. Anyone know what that's called in Google? Okay, Azure Data Lake storage we talked about earlier. Data lakes is pretty much kind of blob storage that you access as data. You sort of do a select on it. So if anyone's done SQL, SQL, if you've done select statements on data in databases, like in relational databases, a data lake, you can do the same kind of like SQL statements, SQL statements on the data, but the data doesn't have to be structured like a table, like rows and columns, as we said before. It can be kind of a little bit more arbitrary, but you can add structure to it in as you use it. So but by using your queries, your SQL queries, you can get the data out in the way you want to get it, that kind of thing. I think that's all I want to say on this page. Has anyone got anything they want to say on this page? Okay, it's getting to 8:30. I was kind of thinking at 8:30 we'd kind of give up and kind of just ask questions if anybody had any questions. Do we want to just stop at this point and we can make part 2 another time and talk about the rest? Does anyone have any questions they want to ask?
I've got one question about the data lakes.
Yeah. Mm-hmm.
So is that something that is typically set up? You know, like you talked about how if you need it for like massive sets of massive data,
yeah,
or it could be for small sets of data. Can you have multiple data lakes?
Oh yeah, you can have lots of data lakes. Yeah. Typically, you're going to have one big data lake, per company that has a lot of certain kinds of information in it, but you'd have smaller data lakes for other stuff. If you think of the old data warehouses, which
Okay.
each cloud still has data warehouses, but if you think of it being as almost like a data warehouse, but the data in it doesn't have to be in columns and rows, and you can view it
like
in different ways.
Data.
Yeah,
That's kind of nice.
So you can view, if you think of data warehouses in the old days, you used to think of like the dimensions or the stars and so on. So if you think of like, you might want to see the data over time, or you might want to see, for example, I used to work for a supermarket. We in our data warehouse, we had data over time, data by store, data by product, data by supplier, what else? Data by warehouse, and so on. Many dimensions and so on of the data. So really a data lake, you can do all of that with as well, but in the data warehouse, it used to have to be fairly structured, whereas in data lakes, it's much more unstructured. And it just adds that flexibility, especially when you're bringing in huge amounts of data and you might not have the ability to cleanse it as much and to massage it into the shape of a table, like with rows and columns. It's really good for that kind of thing. We haven't got to those slides yet, but the clouds all have some method of what's called data ingestion. Data ingestion typically is either real time or near real time. It's getting lots and lots of data in really quickly. And then the data is either stored somewhere or is massaged by some kind of data pipeline or ETL process. ETL is extract, transform, and load. So the data is kind of massaged through that and then stored somewhere that's useful or done some analytics on, that kind of thing. So typically, while it's going through that pipeline, it might be stored in a data lake. And then at the end of that data pipeline or ETL process, it might be stored somewhere else, like in a data warehouse, or there's some other places too. Rick was talking about the files. So we use HDFS, but in AWS it's called EMRFS. EMRFS is really S3 under the hood. It's blob storage under the hood, but on the top end it looks like it's HDFS. It looks like it's Hadoop. So Hadoop is how do I explain Hadoop? It's kind of a way of querying data in different ways using different tools. Hadoop is really a really highly available file storage system. And so it's very highly available. It's kind of always there and it's very reliable. I think it's got 99.99999, something like that availability, crazy. So it's just like S3, which is underlying of EMRFS. So the HDFS and the EMRFS are almost the same thing. So data can end up there, or it can end up in data warehouses typically. And then once it gets into those places, either the EMRFS or the HDFS or the data warehouse, then typically you're going to do some kind of analytics on it or some kind of machine learning on it to make assumptions and make predictions and to find patterns, to predict stuff.
Yeah,
you know, that kind of thing, to show series.
I have 20 plus years of data that
so you know what I'm talking about.
I can't put in, and I've got data that, you know, from when we started to where we are now. And obviously, you know, it's expanded, but the legacy cases, some of which are, you know, the Exxon Valdez case,
right,
is still has emotional issues. Let's put it that way. And so we still pull, you know, there's still data that comes in against that, but the original data from 20 years ago from that spill is not as robust as data that would be on a spill that happens today, simply because we've learned so much. So
that is perfect,
you know,
for a data lake then. Perfect.
That's where I'm wondering if that's the right, and that's the kind of thing that I was hoping that I would get from this, to be able to talk intelligently when I go to put this into a contractor, to not just say, hey, I want a document storage or I want data storage. I want to be able to say, I need this to be a data lake.
Mm-hmm.
I don't want you to try and shove the data into a form that it may not fit, which is what I have contractors that are currently trying to do. They're trying to they're like, well, we cleaned the data. How? You can't clean data from 20 years ago. That's just not going to work.
Yeah.
But we're going to end up having to do some of that when we pick up 20 years worth of data. But I also have legal documents. I can't even tell you how many pages of legal documents that we have to maintain and keep. And then just documents, just paper that physically comes into us that we need to put somewhere. So
now some of that, you know, Glacier is going to be perfect for some of that because it's old stuff that you'll probably never get out of there, or very rarely get out of there. So very cheap storage, right? But then some of that stuff that you are going to need to use in queries, maybe to compare to current data or something like that.
It may be cool versus it may be like that intermediate. I don't need it all the time, but I need to be able to reach back to it. I don't need some of the Glacier. Yeah, I might have to reach back to it because they Congress loves a good, hey, how much how much oil spill recovery money have we spent in Idaho
Yeah.
since the inception? Are you kidding me? Yeah, let me go look.
Yeah. Yeah, I get that. So that's why data lakes are so cool, right? Because you can look at trends over time across all the data. If you've got those particular parts of the data across all of the data for, for history, you can do a select over all of that data and find out the totals or the sums for that, or the average for that, or whatever it is that you want to know. And then if you've got some what we call silos, which in a data lake, typically you'll have silos. So one silo might be your old data and one silo might be your new data, right? So then there might be some things you can only do to the silo that's the new data, and some things you can only do to the silo that's the old data. Do you see the difference?
Yeah.
And so what you might want to do is you might want to do the pipeline stuff, the data pipeline, ETL type stuff, extract, transform, load stuff with the new data, but you don't want to do that with the old data because it just hasn't got enough data there to do that with. So the new data you could put into a data warehouse after you've done the ETL or the data pipeline stuff. It goes into your data warehouse and you can do all your queries, the ad hoc queries that you probably have to do every day. But then occasionally you're going to want to also bring in some data from this old silo. And for example, in AWS, a really good way to do that is Redshift is the data warehouse for AWS typically. With Redshift, you have something called Spectrum that sits kind of on Redshift, and it allows you to query your data lake, your silo, your old silo, as if it was a table in your Redshift data warehouse. So it allows you to do queries across, and it creates views
nice.
and stuff. Yeah, that is nice. So just from what I've heard from you today, that's probably the way I would structure it and architect it. But this is just a very quick conversation, obviously. But that's kind of some of the options, at least, that are available.
I appreciate it. Trust me, you're never going to get rid of me.
That's good.
I took a job to get out of my comfort zone in my current job, and out of my comfort zone.
Well, I can help you get back into your comfort zone, because anything I don't know, Rick will know, or somebody else that I know will know, or Rob, or I've got people in my company. My company is called North Highland. We've got a whole load of consultants. We've got 6,000 consultants worldwide. So we've got a lot of people that know a lot of stuff about this stuff. So if there's something I don't know, I can probably find it out for you. So
I love it.
But it sounds like we need to have a separate conversation. But for anybody else,
I think
any questions?
I think I'm the only one left.
Are you the only one left? Oh no, is everybody gone? I can't see the actual thing while I'm doing my presentation. That's the only thing with Teams. You can't actually see who's still on and who's not on. Okay, yes, it's just us that's left.
Sorry, you're stuck with me.
Good. No, that's fine. So, I mean, it sounds like you've got a lot to think about. We can have like a call another time and just touch base on that. Do you want to?
I would love to.
Yeah, I will put the notes in the PowerPoint and then put the slides on the website. Did you come through Witches? Which one did you come through?
I came through Witches, yeah.
Yeah, I thought
on Meetup.
Yeah. So Witches is a very, very active group. It's women in technology, cloud, hybrid, that engineering software. So that's a really busy group. We do a lot of stuff. So just contact me through there, email me, or the presentation slides will have my phone number and all that kind of thing. So you can contact me any way you want to. Well, thank you for showing up, Beth. It was really good to speak to you. It's
I appreciate it. Thank you, guys.
Project you're doing there. It's very interesting.
Oh, yes.
And thank you, Richard, for all your help and support.
No, you're welcome. I'm going to go have dinner now.
Yeah, I'm going to have dinner too.
I've got to get on another call.
Okay. Oh, dear.
Right, thank you.
Bye, everybody. Thank you.
Bye.
Bye-bye.